In this Doodlecast, we're going to look at Pearson R correlation. And what I'm going to do is look at this data set, and if you'll notice, we have age and driving errors. Both of the variables are from the same person, but they're not two separate conditions. These are two different characteristics or occurrences all at the same time, and they're both continuous variables. So what we're really looking at is, in this research scenario, is people from the age of, they went from 17 to 30 and to look at driving errors, and the hypothesis is that as age increases, driving errors will decrease. So we're going to test this at 0.05 and start going through the process. In step 1, as you know, we're going to state our hypotheses. So it's fairly simple. We're just going to state our alternative hypothesis. And my alternative hypothesis is that as age increases, the number of driving errors will be inversely related. Which this basically means that the driving errors will decrease. So it's just a way of saying basically there will be an inverse relationship between age and driving errors. So we have our data set here in the upper right. Now we have our alternative hypothesis, and we can actually move on to step 2. So if you'll notice, our data set, there is 6 participants with 2 scores for each participant. Look at our step 2. Now in step 2, we're going to set our criteria. Now if you recall, we've been setting our criteria by looking up the criteria in the tables in the back of the textbook. Specifically for Pearson R, we're going to use our degrees of freedom. It's going to equal n minus 2. Now n is how many pairs or how many participants are there? How many x, y values do we have? So in this case we have 6 participants, and we're going to subtract 2 because there are actually 2 individual variables. So our degrees of freedom is going to be 4. Now we're going to go ahead and look up our degrees of freedom for alpha 0.05. Remember, we're doing this one tell. So we're going to look in the back of the textbook. It's page 488, table B5. And we're going to look up 0.05 one tell, and you should get 0.729. Now 0.729 should be negative because we are specifically looking for an inverse relationship. I'm sorry, I'm scribbling here. It's 0.729. So we're specifically looking for an inverse relationship, which would be a negative relationship. So our critical value is 0.729. So if we look, we can see our distribution. We're going to put all of it over here in the left-hand side. So anything beyond this point, 0.729, is going to be significant. So now we have our criteria for rejecting the null. Let's go ahead and move on to step 3. So in step 3, we're actually going to calculate our R obtained. So we're going to have R equals the sum of the products divided by the square root of sums of square for x times sums of square y. So let's work on getting what we need. So the first things we're going to need is our sum of x and sum of y. So sum of x is we're just going to add up our age, because that's our x variable. We're saying age predicts the number of errors. So 19 plus 24 plus 20 plus 17 plus 29 plus 22 is 131. And then we're going to get the sum of y, which is our outcome variable, which is 5 plus 2 plus 1 plus 7 plus 0 plus 1. And we should get a sum of y of 16. Now, we're going to go ahead and we're going to need basically our xy, our sum of xy. So what I do is I always add kind of a little column, x times y, because what we're going to do is multiply every x variable to its y variable. So 15 times 19 is 95, 2 times 24 is 48, 20 times 1 is 20, 7 times 17 is 119, 0 times 29 is 0, and 22 times 1 is 22. Oops, not 20, but 22. So is what we're going to do, I'm going to put a little arrow, is make a note. That is our sum of xy when we add those up. So when you add 95 plus 48 plus 20 plus 119 plus 0 plus 22, you should be getting 304. Now remember, we're going to need our sums of squares for x and our sums of squares for y. So we're going to need our sum of x squareds for each of these variables too. So when calculating, 19 squared plus 24 squared plus 20 squared plus 17 squared plus 29 squared plus 22 squared is going to give us our sum of x squared. And I got 2,951. And then our sum of y squared is the errors, 5 squared plus 2 squared plus 1 squared plus 7 squared plus 0 squared plus 1 squared. And I ended up with the sum of y squared equals 80. So now we can easily get our sum of x and our sum of y, sums of squares x and our sums of square y. So when I get sums of squares x, I'm basically doing 2951 minus 131 squared divided by 6. And the sums of square y, I am doing 80 minus 16 squared divided by 6. So our sums of square x ends up being 90.83. Our sums of square y ends up being 37.33. Sorry, this is all running together, but we're going to need this information. So now we have those two. So we can actually, believe it or not, plug those in. So we'll do 90.83 times 37.33. Okay, I'm going to put a little x there for times. And we're going to have the square root of that. And then we need to find our sum of the product. So sums of square x, y equals that sum of xy, so the 304, minus, and then the sum of x, so 131 times 16, the sum of y, all divided by 6, the sample size. So when you get that, you should be getting, and this is the one time with a sums of square because it's the sum of the products, you can get a negative. You should get negative 45.33. So now we have the numerator. Okay. So when we calculate this out, don't forget to take the square root of the denominator. You should be, and I'm going to write it down here in blue, but our R obtained after calculating, you should be getting negative 0.7785. Now we do need to calculate an effect size, which is very simple. We're going to just square our R. So we're going to square 0.7785. And your R squared, which is your effect size, your coefficient of determination, should be 0.6060. Now each of these will be rounded to 2 decimal places, but you've done all the calculations needed for your test statistic, and now you just need to see whether it's significant. So if we look at 0.7785, which is rounded to 0.78, if you look back at our critical criteria, here is, negative 0.78. It's over here. So we know that it's significant because it's in the critical region, so we can reject the null. And now we can go ahead and write our APA results. We're going to go step 4, writing our APA results. So our APA results are just basically going to regurgitate our alternative hypothesis. But I'm just going to put here age was significantly related to a decrease number of mistakes. Specifically driving mistakes. And now we're going to do the APA portion. R equals negative 0.78, N equals 6, because that was our sample size. This is a different format than the t-tests. P is less than 0.05 one-tail, because we used 0.05 one-tail, and we have our effect size, which is R squared, which equals 0.61. Now you've just went through the entire Pearson R analysis and have your APA results. Good luck on your Pearson R activity for your hybrid week 14. And if you have any questions, please shoot an email to me and I will answer anything you need.
Made with Doodlecast Pro.